Everyone, so this is the 13th lecture of the course, and we're going to start with wireless sensor network medium access control protocols today. Okay, so there are actually many MAC protocols in WSN because the wireless sensor networks has many applications and many environments in which they are deployed, and depending on those environments the MAC protocols change a lot. So there are a huge number of MAC protocols. So wireless sensor network MAC protocols or medium access in wireless sensor networks is difficult because of various reasons. Some of them are it's impossible to send and receive at the same time because there's only a transceiver in a wireless sensor network. If you remember, we read the different components of a wireless sensor network, and there were four necessary components, one of which was a transceiver. And transceiver means it can receive and transmit using the same antenna. And the other problem regarding wireless sensor networks or nodes of wireless sensor networks is you cannot create multiple antenna because it would be very costly, as wireless sensor nodes have to be created with the least cost possible or in the least expensive manner. As a result, you cannot create more than one antenna, and so one transceiver is used for both receiving and transmitting. As a result, it is impossible to do both at the same time. So due to this, collision detection is not possible. So the other reason is another reason is interference situation at receiver is what counts for transmission success, but can be different from what the sender can observe. So this is quite simple, right? If a message is sent from the sender to the receiver, collision actually happens at the point of the receiver. So even if there is a collision at the point of the sender, there might not be a collision at the end of the receiver. Similarly, if there is no collision at the end of the sender, there might still be a collision at the end of the receiver. So the most important thing to detect a collision is to understand the situation of the receiver, but it is difficult to do that in case of wireless scenarios because the signal range decreases as it goes to a specific distance. Okay, so this is another problem why collision cannot be detected, and interference situation at the receiver cannot be understood as well. And another problem is there are very high error rates in wireless communication because there might be multiple kinds of interference and, let's say, natural reasons for the data packets to be dropped and errors or corruption to affect the packets. Okay, so the requirements for WSN MAC protocols are similar to normal wireless networks, which are, let's say, we need high throughput and we need low overhead, we need low error rates and so on, right? But there are some extra constraints when we are talking about wireless sensor networks, which are energy efficiency and also the handling of devices. Okay, so handling of devices means you have to handle both the turned on devices and turned off devices. Okay, so that means that nodes can turn off in case of wireless sensor networks to preserve their energy. So you have to schedule when the nodes will be turned on and when it will be turned off. Okay, so the one thing that's most important here is in case of wireless sensor network, the strictest constraint is related to energy efficiency because you cannot replace the batteries in most of the cases for wireless sensor networks, and you cannot fix the networks as well. So the wireless sensor networks and the nodes of wireless sensor networks have to be self-organizing, and their battery life needs to be conserved in the strictest way possible. So energy efficiency can be considered the most important constraint when we are talking about wireless sensor networks. Okay, because the nodes are usually disposable. So as a result, a large number of nodes needs to be created, and as the number of nodes is huge, it's even more impossible to replace those batteries. Okay, and the other thing is the different layers which work with everything. For example, the application layer, the network layer, the data link layer, and so on. So these layers actually define the protocols, right? And as energy efficiency is determined by the medium access control. Why is that? Because receiving and transmitting is the most expensive work you can do with consideration or with respect to energy, okay, because that is the most energy consuming application of wireless sensor networks, okay. So as a result, the medium access is very important to ensure that there is energy efficiency, which is why MAC protocols have to be very conservative when we're talking about energy. So the requirements for energy efficiency are, as I've already said, the transmissions are very costly and receiving is also costly compared to transmitting, okay. So both of them are very costly. As a result, both receiving and transmitting must be avoided as much as possible. And idling can be cheaper. Idling means you're not receiving but you're not also transmitting. Idling can be cheaper, but even that is expensive. So you can clearly understand the importance of energy in wireless sensor networks, okay. So some problems are listed here which says that which sort of actions actually cost us energy and which actions we should avoid. So the first one is collisions, okay. So collisions are very wasteful. Why? Because not only did the packet that you sent using a lot of energy is wasted because there is a collision, but you have to again send those packets, okay. So this is a wasted effort when packets collide. The second problem is overhearing, okay. So what does overhearing mean? Overhearing means, let's say you are listening in on a packet which is not intended for you. So let's say one station is communicating with another station, but you are in between and you are not sure whether that packet is intended for you or not, and you are listening in on that packet, but after you receive it you understood that it's not for you. So the time and energy you wasted here cannot be got back, right? So this is called overhearing, and in short it can be said the waste effort in receiving unintended packet. Another reason is idle listening. So idle listening means idly trying to receive when nobody is sending. So the difference between overhearing and idle listening is, in overhearing someone else is actually sending a packet and you are listening to that, and idle listening means you're listening but no one is sending the packet, okay. So this is less costly than overhearing, but it's still very costly. As I've already said, that idling can be cheaper but it is still expensive, so we even have to avoid idle listening. And next is protocol overhead. So protocol overhead means the time or resources spent to control the medium access, okay. So any sort of medium access protocol or medium access control mechanism that you provide for the wireless sensor networks, even that protocol has to be simple so that the wireless sensor networks do not waste enough resources to access the medium or to implement the protocol, okay. So there are many constraints here, as you can clearly understand, and a low complexity solution will always be nice to solve all these problems, but that is very difficult to come by. So this is the classification of medium access control for wireless sensor networks. Although this is a basic classification that I have tried to build, you can find various kinds of classification, because as I've already said, there are many kinds of medium access control protocols, and many of them do not even fall under one category. They might be a mixture of multiple categories, okay. So what's important is to try to understand each type, okay. So instead of understanding which is divided into what, you need to understand each specific type. So I'm going to go through all of them in short. So wireless medium access can be divided into two categories: centralized and distributed. So you already know what centralized and distributed mean, right? Centralized means someone is there to control the mechanism or medium access, and distributed means the control is given to everyone. So these two can be actually divided into two ways, both of them. One is schedule based and one is contention based. So schedule based means the schedule is given, that means there is a fixed slot for someone to access the channel, and contention based means they have to content for the channel, okay. And fixed assignment and demand assignment means for fixed assignment the schedule based application is used here. So that means whenever you want to set a schedule, you only set a schedule when you need to. So that is called demand assignment, and when the schedule is already fixed from before, this is called a fixed assignment, okay. And in case of contention based, there are two types: synchronous and asynchronous. So synchronous means before transmitting, the nodes need to synchronize with each other. They need to synchronize the time periods of waking up and sleeping, okay. So what is waking up and sleeping? We're going to see that later on. And asynchronous means you do not have to sync with the other stations, okay. So I've explained all of these in short, but don't worry, I'm going to go a little bit in details. So centralized medium access. a central station controls when a node may access the channel. Okay, so this means, as I've already told you, there has to be a station who controls the medium access. Now the problem here is, in case of wireless sensor nodes, as all of the nodes have to be what? Disposable, right? So I cannot actually create a sensor node which will be very costly, like an access point, or which has more power. So what happens in most of the cases is the sensor nodes take the control of the scenario in shifts. For example, when one sensor node is acting as the central station, it is using a lot of power and lot of energy, and as a result it might finish its battery life before everyone else. So after a specific amount of time, the duty is again shifted to another station or wireless sensor node. Okay, so in this way actually a central station can control. Okay, so examples can be polling, then centralized computation of TDMA schedule. So TDMA means time division multiple access. That means the computation of time slots for each of the stations that can be done by the central station. Okay, and polling is simple, just polling each of the stations to know who has the data to send. You have already seen examples of that. So features of this protocol is it's very simple because it's controlled, right? And it's quite efficient because there is no collision, because instead of contending, now the central station determines who will access the channel, so there is very less collision. But the problem is it burdens the central station more. As I've already said, the central station has to use a lot of energy. So this is not directly feasible for non-trivial wireless network sizes. Okay, so non-trivial means when the wireless network is large in size. That means there is a huge number of nodes even when we are comparing with other wireless sensor networks. So why is it not directly feasible at that time? Because the more number of stations there are, the more burden it is for the central station. So the central station will burn out its battery life very quickly. As a result, it is not possible to use a centralized medium access when there are many sensor nodes. It can only be possible to use this protocol when the number of sensor nodes is fewer in comparison. Okay, so it can be quite useful when the network is divided into clusters. Okay, so if there are smaller networks, if I can divide the large network into some smaller sub networks or clusters, and let's say assign a central station for each of those clusters, then maybe the central station can handle the load. Okay, so it can also be compared with piconets, right? If you remember piconets of Bluetooth networks, so there were about 8 stations in a piconet, right? So that sort of small network with only 8 stations can be used to apply the centralized medium access. Okay, so each cluster has centrally controlled medium access, as I've already told you. So each separate cluster will have their own medium access control mechanism. Okay, so they will be following a different schedule, maybe each of those, or maybe following a different slot, and the mechanisms of one cluster will not affect the other cluster, so it will be easier to manage them as well. So the next type was schedule based medium access control. So in this scenario, obviously a schedule exists which regulates which participant may use which resource at which time. Okay, so this is simply you can compare it to time division multiple access. Okay, you have already studied it right before, TDMA, CDMA. Okay, you must have studied it before. So the typical resource can be, it can also be a time. That means the time slots will be divided, or it can also be that the frequencies can be divided in a physical space. For example, FDMA, right? So FDMA can also be used. It can be any kind of schedule, not only time based. Okay, so again, with a given code, it can also be code division multiple access. So all these kinds of division mechanisms which divide the virtual space or physical space among the different nodes can be considered as schedule based medium access controls. Okay, so the schedule can be fixed or computed on demand. As I've already said, the schedule can be fixed from the beginning, or when the stations want to access the channel, only then it can be computed on demand. Okay, so usually collisions, overhearing, and idle listening, these are the problems that we mentioned earlier, right? So usually these problems are solved when we're talking about schedule based mechanisms. Okay, but the requirement here is there needs to be a time synchronization. Okay, because all the nodes need to know when they can access the channel. They need to know their time slots. As a result, they need to synchronize their time, or maybe synchronize their frequency. Okay, so next is contention based medium access control. So in case of contention based medium access control, as you can understand, there is no central station, so the risk of colliding packets is deliberately taken, okay? Because in case of contention based mechanism, there is always the possibility that many stations will try to access the channel at the same time and there will be a collision. But why are we doing this? We are hoping that the coordination overhead, there has to be a coordination overhead when we are working with a central station, because that has to coordinate with the other stations and let them know when you can send, okay? So this control overhead or coordination overhead, if this is too much, then the centralized medium access can be actually more harmful than beneficial. So our hope in contention based mechanism is it can be better than centralized access if the coordination overhead can be saved, okay? So resulting in overall improved efficiency. So if, let's say, the coordination overhead is not much, then the colliding packets, which is the risk of colliding packets, okay, so this will actually be more harmful compared to centralized medium access, okay? So you can clearly understand, basing on the environment and the requirement, the medium access controls have to be decided. Okay, so in case of contention based medium access control, there are mechanisms to handle or reduce the probability of collisions, okay? So obviously without those mechanisms there will be a lot of collisions, so we have to reduce those with the protocol. So usually randomization is used somehow. You already have an example in WLAN. In WLAN, some sort of randomization is also used to select the contention window. So similar protocols are used in case of contention based MAC for WSN, okay? So WSN MACs can also be a combination of strategies, so it is difficult to categorize a protocol into a specific category, as I've already said. Okay, so next we are going to see already well-known protocol, which is a sensor MAC, okay? So remember, we are going to study a few protocols in this lecture and also in the next lecture as well. So most of these lectures or protocols are actually very old. They might be from the range, maybe 2002 to 2004, okay? And many other protocols have actually replaced them or improved them, okay? But they're the foundation of wireless sensor networks, and the citation for each of these papers have exceeded about 7,000 citations, okay? Which clearly explains how important these protocols are, okay? So if you want to study new protocols, for example, TMAC came after SMAC, it's up to you to study those, okay? And they can even help you if you want to do research on wireless sensor networks, but I'm not going to explain the new protocols. I'm only going to explain the most basic and well-known protocols. Okay, so let's move on. Sensor MAC or SMAC. So this protocol is a synchronous type MAC protocol. That means it synchronizes with the other stations, okay? So there is a duty cycle, which is why it is also called duty cycle based MAC. So what does a duty cycle mean? A duty cycle means a sensor node does not stay awake for the entire period. No, it only stays awake for a very small amount of time, and the rest of the time it sleeps, okay, or it goes into a low power mode. So you can see the figure here. So let me just turn on the laser. Where is the laser? Okay, this one, I guess. Found it. Okay, so as you can see here, this is the timeline, right? And this small part is actually the time during which the station will stay awake, and this time in between the wake up time is the sleep period. So during this time the station will be sleeping, or it will not be awake, okay? So this small time is actually only the active period. So you can clearly understand a lot of energy is saved as a result. So this entire period is called the wake up period. So remember, wake up period is not active period. Wake up period is the summation of sleep period and active period. So wake up period is the amount of time during which if another station is listening, then it can clearly understand when that station is active, okay? So this is required to understand which stations are active. Okay, so let's go through the idea one by one. So the idea is the switch, we have to switch nodes off to ensure that the neighboring nodes turn on simultaneously to allow packet exchange. Okay, so let me clear this up. This means that the switches will always be turned off, but we have to only turn on the switches when the neighboring nodes are also turned on. That means all the nodes have to be turned on at the same time so that they can sync their active period, so they can also sleep for a longer period of time. Okay, they also need to exchange wake up schedule between the neighbors. Okay, that means there have to be a communication between the stations so that they know when the other station will be awake. Okay, and only in these active periods packet changes will occur. During the sleep period there will not be any packet changes because the stations will be sleeping. So it's simple, there will be no packet changes during the sleep period. There will only be packet changes during the active period. Okay, so when the stations are awake, they essentially perform RTS or RTS and CTS. Okay, so after RTS and CTS, then they start their communication. So at first what do? They use a sync packet to synchronize their time. Okay, and after the sync packet they send an RTS and then a CTS, and which is the handshaking protocol, and after RTS and CTS then they start communicating. Okay, so so the nodes try to pick up schedule synchronization from neighboring nodes. So in order to understand the schedule of the other nodes, or to wake up at the same time as they wake up, you have to understand their schedule. So you have to synchronize your schedule with the schedule of the other neighboring nodes. So if no neighbor node is found, then you can actually pick any random schedule to start with. So if any additional nodes join, they will join your schedule. Okay, so some node might learn about 2 different schedules from different nodes. So at that time what will happen? Synchronized islands will be formed because they have to synchronize with multiple nodes. Okay, so what does synchronized islands mean? We'll see that later on. So to bridge this gap, it has to follow both the schemes of both the neighboring nodes. Okay, so in this scenario actually that node has to use more energy compared to the other nodes. So the following demonstration shows the process. Okay, so let's see. At first, let's say one station A has suddenly woken up, and as I've already said, if there is no other station nearby, then it will randomly select its own schedule. Okay, so as there is no station nearby, it will select its own time period. So as you can see, these are the wake up time, the active periods of station A, and the other times it will be sleeping. Now another station C has woken up, but it is far away from station A. That means it will not receive anything from station A. So we can also consider that in this scenario C will select a random time for itself, but it will not match with the station A. So their time periods will not be synchronized, but they both will select a random time. So let's see, also selects a random time, and this is the time schedule for C. The active periods is the blue marked one, and the white timeline is actually the let's say the sleeping period. Okay, so next station B has woken up, and now station B is near to A. So as a result, B has to synchronize its time with station A. So this is what happens when it synchronizes its time. So B will only be awake when A is awake. Okay, so if you remember the wake up period so during the wake up period, that means the addition of the sleep period and also the active period. So during the whole wake up period, when station B will be awake, so during this entire period it will be trying to listen to A, and whenever A sends the synchronization packet, if you remember SYNCH, right, whenever A sends the synchronization packet, only then B will understand that okay, so this is the time period of A, and the information of the time period is given in the synchronization packet, and when B gets the synchronization packet, then it will fix its own time schedule to match with A. Okay, so this is what happens. The schedule of B now matches with A. Fine. Another station D has woken up. The same thing happens like B, and it matches its schedule with C. Okay, so now the problem is the problem of synchronized islands. So now the problem happens when, let's say, another station E has woken up, but now it is in between B and C. So it can actually receive from both B and C. Otherwise, there will be no communication with B and C, right? So there has to be a node in between B and C. So when a node arrives or wakes up in between B and C, now the problem arises. What will it do? Will it match with the time of B, or will it match with the time of C? So in this scenario, it has to match with actually both of them. So this is what happens. sorry, so this is what happens when you try to, when station E tries to synchronize with both the stations. It has to stay awake for a longer period of time compared to the other nodes. Okay, so this is called a synchronized island. Why is it called a synchronized island? Because this part is synchronized by themselves, but it is not synchronized with the other part, which is why they can be called an island, but a synchronized island, because an island is not connected with any other land. It is surrounded by water, right? So that's basically where the definition comes from. Similarly, this is also a synchronized island. So synchronized islands are connected with a node which actually uses much more energy compared to the other nodes, because they have to wake up for a longer period of time. Okay, so this is a problem of synchronized islands. Okay, fine. So that was about SMAC. So next we're going to learn a little bit about another protocol. We can actually call it a technique more than a protocol, but it's also used as an entire protocol when a preamble is also used with it. Okay, so this technique is called LPL, or low power listening. So this is the polling type MAC. So what does LPL mean? LPL mean that means the nodes will be in a low power mode, so that it cannot receive packets, it cannot send packets, but it can only detect whether there is an energy level in the channel. That means it can only detect whether the channel is busy or not. It can only detect when someone else is sending packets or not. So the goal here is to minimize the listening cost. So if you do not have to wait to receive the packets, or if you do not have to be ready to receive the packets, you can only check for the energy level of the channel. So as a result, the listen cost is minimized. So the principles of this technique or protocol is the node periodically wakes up, then turns the radio on and checks the channel. Okay, so the wake up time is fixed. So how is the wake up time decided? That is depending on the received signal strength. Okay, so RSSI means the received signal strength. That means the node tries to understand which signal power is the strongest. Okay, so this is similar to if you remember in wide area networks, when a mobile tries to get inside let's say a cell, it tries to understand which BTS tower has the strongest signal, and by understanding that, it tries to access the channel of that BTS tower. So that is called RSSI sampling. Okay, to sample the signal strengths and to choose the signal strength which is the strongest. Okay, so what happens in low power listening is whenever it's waking up, instead of trying to receive a packet, it only tries to assess the signal strength in the channel. Okay, so this is actually the check time variable. So that means this is the amount of time when the node will be trying to assess the signal strength of the channel. Okay, so if an energy is detected, then the node powers up. That means now it will be ready to receive the packet. Otherwise, it will be in a low power mode. Okay, so this is in simplicity what is the low power listening. So the node goes back to sleep if a packet is received. Once a packet is received, you do not have to wake up anymore because your work is done. Or if you are waiting for a long amount of time with low power listening mode, but no packet is received, even though the channel is busy, you are not receiving any packet, so it will stop listening after a timeout amount of time. Okay, so if the preamble length matches the channel checking period, then you will understand that someone is sending a packet to you. So why does this come? Because if you remember, you can only check whether the channel is busy or not, but you do not know whether any packet is intended for you or not. So in this scenario, the preamble is used to understand whether any packet is intended for you or not, and the preamble is also used to synchronize. Okay, so whenever you receive a preamble, that means preamble is actually a series of zeros and ones, and you should have learned this in the previous courses as well. So whenever you receive a series of zeros and ones, that means that you have to wake up and someone might be sending a packet to you. Okay, and if that preamble length matches the channel checking period, then you do not need any synchronization. That means you are already synchronized with that preamble. Okay, so the LPL mode with preamble. Now if there is preamble along with LPL mode, then it becomes a protocol. Okay, so with these two things, a new protocol can be formed. So in this protocol, the scenario is, I will explain from the beginning. At first, a preamble is given, and whenever a node listens to that preamble, it understands that okay, someone might be sending a message, and it wakes up from its low power listening mode. And after it wakes up, now it is ready to receive any packet. So if it receives a packet, and if it understands that this packet is intended for this receiver, then after receiving the packet, it will go back to sleep. Otherwise, it will keep waiting, and if no packet is intended for the receiver, after a timeout period, it will again go back to sleeping, or go back to low power listening in this case. Okay, so this is the low power listening with preamble in short. So that was the end of the slide. If you have any question, then please feel free to ask. And in the next lecture, we'll also be learning a few more protocols of wireless sensor network, medium access control. Okay, so if you have any question regarding everything that I've said today, you can ask. Okay, so with this, I'm going to end the lecture for today. Assalamu alaikum everyone.